have had several people say that they need a little better explanation on 9.7. So I'm going to create this new video for it. So again, this will go along with your 9.7, and these are word problems, so you're gonna have to pay attention and then see what I'm writing on the board from it. So on number 1, yours will go something like this. In 2012, the population of a city was 5.06 million. So in 2012, the population was 5.06 million. The exponential growth rate was 3.44% per year. Okay, so that's what we're starting with. The population in 2012 and the growth rate was 3.44% per year. Now, this section is on exponential growth, and the equation, the formula that we use for exponential growth is the population at a certain time in years is equal to the population of sub-zero. So this right here means what was the population at the beginning? That P is 0 means what's the population of the beginning? E to the KT. So this is the formula that we use. This right here, the 3.44, that is your K. The rate is your K. So the first thing it wants you to do is say the exponential growth function is, for using this information, is P of T. It gives you that part. Now, the first thing you're going to plug in, this means the population at the beginning of the situation. So let's see, that was going to be 5.06. Now, there's your E, which we learned about in a previous section. Now, the K is something else that we know, because remember, that's the rate. Now, when we plug this into the formula, though, we want to put it in decimal form. So what does that mean to do? That means to move this decimal and this percentage 2 places to the left. So if I move this 2 places to the left and plug in a 0 in that missing spot, it's going to be 0.0344. Now, here's what we don't know. We don't know the T. So that right there is still a T. So that's what you're going to put in on the first blank for the A, okay? On the A part of your question is simply wanting this formula. Now, that's what we're going to use to solve the rest of the problems. The B part says the population of the city in 2018 is blank million. So let's think about that. What do we know now in 2018? What would be the population following this model? Well, if we know this year is 2018 and the beginning year is 2012, so let's see. That means it has been what? It has been 6 years since the beginning, since from 2012 to 2018. It's been 6 years, which means now I know what this T is. The T is going to be 6. So essentially what you're finding now is P of 6. What happens when you plug 6 in for that T in your formula? So let's see, P of 6 would be 5.06 E. Still, the exponent up here is 0.0344. Instead of putting in this T, now what can we find? What do we know that is? That's a 6. Now, you simply just plug that into your calculator. So let me show you what that would look like. So I'm plugging this right here, 5.06. Now, you'll see this E right here, E to the X is right above that LN button. So remember, to get to that E to the X, I'll need to push the second button, right? That's what'll get me to the E. So second LN will get you the E that you need. And look, it automatically puts the cursor up into the exponent. So it's ready for me to type in this exponent right here. So 0.0344 times 6. So you can either put parentheses with a 6 in it, like that, right? That'll do times 6, or just put in times 6. So that right there, 5.06 e to the 0.0344 times 6, and hit enter. And mine tells me this right here, 6.219978706, but it tells me to round it to the 1 decimal place as to 1 decimal place. So if I have 6.2199, if I round this to 1 decimal place, that means it wants my answer to stop right after the first number after the decimal. So look right after this blue line that I drew and see that it's a 1, which means I just don't need to round this 2 up, right? It stays a 2. It only would round up to a 3 if the number after that was 5 or higher. So you would just put in 6.2 as that answer, okay? Now, the next thing on the C part, the population of the city, let's see, so I'm going to erase. I want to keep this formula. Because that's what I'm still using, is that formula. So let's see, I'm going to rewrite it up here because I'm going to need this whole board for this part. So again, my formula that I'm using is P of T equals 5.06 e to the 0.0344 t. So let's see, in the C part of this situation, what do we know? The population of the city will be 9 million in about how many years after 2012? So let's see what I know now. Now I know this right here, this stands for the population at the end of the time that you're counting. So I do know what that population is now. It says the population's going to be 9 million. So 9 goes in place of that. What are you looking for? It says the population will be 9 million in about how many years? So this time, this T, that's the number that stands for the years, right? Remember in the last part, that's why we put that 6 in there, because it told me 6 years. Now this is what I'm looking for, is the time. So that's what I don't know. So I do know there's going to be 9 million people. We started off with 5.06 million people, e to the 0.0344 t. So now we're solving for t. Now remember, how did we get the letter that we are solving for is up in my exponent. The rule that we use to get the variable out of the exponent and down here is we're going to log, or in this case, we're going to ln both sides. But before we do that, remember, I just need all of this to go away so that t is by itself. Well, I can make this 5.06 go away right now. Since it's hooked on, I'm going to divide by it to cancel it out on both sides. So it cancels it out here. So now let's see what we have. On the left, we've got 9 over 5.06 equals e to the 0.0344 t. So now is the time to get the t out of the exponent down into the good part of the problem so that I can solve for it. So the way that I'm going to do that, because here, the rule that we're going to use is if you have log base 10 to the 10th of 10, now remember what happens here, that is equal to 1, right? So what I'm going to use is, instead of log base 10, I'm going to use ln. That's the natural log. So I'm going to ln both sides. If I ln this side, I'm going to ln this side. Now remember, when you log a side, that's the property of logarithms that we're going to use to, this comes from that previous section. We're going to use that to bring the exponent down to the front right here. So let's see, what do we have on the left? We still have ln of 9 over 5.06 equals Remember, when we natural log this side, it brought this down. So now I have 0.0344t came down in front. I still have the ln-e, but ln-e is equal to 1. So if you multiply this by 1, it doesn't change it. So I don't even need that. That's gone away. So look what you have now. On this side, remember, you're solving for this t. You want this t by itself, which means the only thing that needs to go away now is the 0.0344. And since it's hooked on to the t, what am I going to do to get rid of it? I'm just going to divide by it. 0.0344. If I divide this side to cancel that, I got to divide this side. 0.0344. So let's see what I have left. On the right, there's my t all by itself. So once I do this side, I'll have my answer. And this you just put in your calculator. So hit your ln button. Now once you hit your ln button, it gives you an open parentheses. In that first open parentheses, I'm going to put in 9 over 5.06. 9 divided by 5.06. And then I'm going to close the parentheses. So I'm there. Now I could hit enter and then hit divide by 0.0344, or I could just put it at the end of this. So I'm just going to, after this, I'm going to say divided by 0.0344 and hit my enter. Look what I get when I hit my enter, 16.7400, all that. And what does it say? Round to 1 decimal place as needed. So again, I want to stop after that 7. And since that's a 4 after it, the 7 doesn't round up. So it'll be in 16.7 years where the population will be 9 million. So 16.7 will be your answer. So again, we knew the 9 million was the ending population. That's the starting population. E, there's your rate. The time is what we didn't know. And if you're solving for something, the variable that you don't know is in your exponent, that's when you're going to have to ln both sides. That's what's going to bring it down out of your exponent. Okay? All right, let's look at the last part of number 1, the D part. All right. The doubling time is about how many years? Here's what the formula for doubling time is. ln2 over k. And remember, k is the rate, which is this number right here. Okay, so the doubling time, that's what my answer is going to be, is ln2 over my k, which is 0.0344. And then just type that into your calculator. So you have ln2 divided by 0.0344. So again, it should just look like that. ln2 over 0.0344. Hit enter. Let's see, it gave me 4. Oh, hang on. Did something wrong. What am I typing in wrong? Oh, careful. How you type it in. I had to put ln2 close parentheses and then divided by 0.0344. So that tells me here that the doubling time, the time it's going to take the population to double, rounded to 1 decimal place. So let's see, I've got 20.149. So again, rounding to 1 decimal place. So I wanted to stop after the 1. So let's see, 4, once again, doesn't round it up. So it's just going to be 20.1 years. So again, what this is saying is it will take the population, if it's growing at this rate, at 0.344, if it's growing at that rate, it'll take it 20.1 years to double. Okay, number 2. Gives you a chart, and it says the population country A, country B, and then let's see. The growth rate and doubling time. And it gives me country A is growing at 1.1%. It doesn't tell me what the doubling time is. In country B, it tells me the doubling time is 24 years. So you're looking to fill in these 2 blanks. So remember, doubling time is ln2 over the rate. So let's see. I'll be able to figure out doubling time by knowing that rate for country A. So let's see. The doubling time for country A will be ln2 over the rate. So since the rate is 1.1, I need to type that in as a decimal. So move this decimal 2 places to the left. So it'll be 0.011. So again, let's type that in. ln2. So ln2 over, so divided by 0.011. Hit enter. So 63.01, and what does it want it to do? Let's see. Round doubling time to the nearest whole number. So since it's 63.01, the nearest whole number would be 63 years. So it's going to take 63 years for the population to double if it's growing at 1.1%. Now, the second one, let's see. What I'm trying to find now is how fast is country B growing? What's its growing rate if it took it 24 years to double? So this time I'm looking for the growth rate. So let's see. Doubling time is 24 years equals ln2 over, this time I don't know the rate, right? I know the doubling time, which is the T of the formula, because remember that the formula is doubling time equals ln2 over K. So this time, what do I know? I know that the time it took is 24 years. And I know the top is always ln2, and the bottom down here is the K, which is what I do not know. So I'm solving for K. So let's see, I need to get it out of the denominator. So let's multiply both sides by K to cancel that. So K times 24 gives me 24K equals ln2. What am I solving for? I'm trying to find the rate, which is the K, which means now I just need to get rid of that 24. So I'll divide both sides by 24. So my K is going to equal whatever that ln2 over 24 is. So ln2, and remember, it likes for you to close the parentheses after the 2 before you put the division in. So divide by 24. And it tells me 0.2888, and I'm looking, let's see, what does it tell me to do? The nearest tenth. So if I'm at 0.0288, let's see, first of all, we need to turn it to a decimal. So we'll move this turn it to a percent, I'm sorry. So it wants me to put it there. Then it wants me to round it to the nearest tenth. So right here, what is this 8 going to do to this 8? It's going to round it up, right? So it's going to be 2.9% is going to be the growth rate. 2.9%. All right, number 3. All right, suppose that $10,906 is invested at an interest rate of 6.8% per year, compounded continuously. So let's see, $10,906 is invested at a rate of 6.8% per year. And it's compounded continuously. Now remember in the section before where it was compounded quarterly or biannually, that would tell you that you would have to use a certain number. But if it's compounded continuously, that's telling you that's when you use the E in your formula. The E is what you use for compounded continuously. So I'm using the same exponential growth rate formula that I've been using. So let's see. P of T is going to be equal to the amount of money you had at the beginning, so 10,906 E. Now, remember, up here is K T, which is the rate times the time. Now, I do know what the rate is. They told me it was 6.8%. So I need to put it in as a decimal. So let's move it 2 places to the left and fill in my blank with a 0. So 0.068 is what I'm going to use for the rate. And then I do not know what T is. So that's going to be the formula. So when you're on number 3, that's what you're going to put in for the A part of the answer. It just wants to know what the formula is. So P of T equals 10,906, which is how much you put in at the beginning. E, going up into the exponent, 0.068 T. Now, the next B part of the problem, it says the balance after 1 year is what? So what do we know now? Now we know the time. We know the time is 1 year. So we're actually finding P of 1, which just means go to your function and replace the T with a 1. So 10,906 E to the 0.068 times 1. So let's see, just how much money will we have after 1 year if we put in this amount, and it's growing at 6.8%. So 10,906. So again, just 10,906. Now I need the E button. And remember where E is. It is second LN, right? Because E is above the LN. So there's my E. And remember, it automatically jumps you up into the exponent. So just type in what your exponent is. It's 0.068 times 1. So your exponent should look like, where is it? 0.068 times 1. Hit enter. So there's how much money you would have after 1 year. And it wants you to round it to 2 decimal places. Since it's money, it wants you to show the cents. So this gave me $11,673.40405. So cents would be right here. So let's see, 4 won't round that up. So again, I'll have $11,673.40. Now the second part says the balance after 2 years. So all we're doing here, I'm not going to work out all of these. So after 2 years, now what are you finding? You're finding P of 2, which just means change your T to a 2 now and plug that in to your calculator. So again, just like we did before, so 10,906 E to the 0.068, but instead of times 1, now we have times 2 because it wants 2 years. So you'll do the same thing. My next one says after 5 years, and then it says after 10 years. So again, you're just changing that T to however many years it wants you to put in there, and then rounding your answer to the nearest cent. Now, the doubling time, again, what is doubling time? So this is the C part of the question. Doubling time is always ln2 over your rate, which this right here is your rate, right? So 0.068. So let's see what the doubling time, how long would it take for you to double your money if you put in this amount and it was growing at 6.8%? So let's see, ln2, again, close your parentheses after the 2, and then divide it by 0.068 and hit enter, and it shows me 10.1933, and it wants me to round it to 1 decimal. So again, it wants me to stop after 1 decimal place. So let's see, this 9 will round that 1 up to a 2. So it'll take 10.2 years for your money to double. All right, number 4, and I think this is where people started getting a little frustrated if they weren't already frustrated. Okay, so because now we're talking about, instead of exponential growth, we're talking about exponential decay. So instead of the things going up, they're going to be coming down. So there's one little thing that we're going to change in our formula. So the data in this table, so it's giving you a table, shows that the percentage of adults in a country who are currently married is declining, assuming that the percentage of adults who are married will continue to decrease according to the exponential decay model. So when we're talking about decay, we're going to use M instead of P. So it's very similar. So this is the amount at the end. That's my ending answer, the amount of people married at the end. This M0, that's the amount at the beginning. That's your beginning amount. Just like in the previous problems, when you deposited that 10,906, that was your beginning amount, right? So your beginning amount always goes here. This is your end amount. E, now look, since we're going down instead of up, right? The numbers are going down, it's saying, instead of up. So this is why you're going to have a negative rate. So your K is going to end up being with a negative in front of it, and the T is still time. So let's see. It says, and I'm just going to write the beginning part of this chart and the end, because that's all we're going to need, instead, and not all the ones in the middle. Oops. So in 1960, it is saying there are 72.2 million percent. That's the percent of adults who are married. Then I'm going to skip these, and then it says in 2012, there's only 45.9% of adults married. Okay, there's some other stuff in here, but these are what we need. So let's see if we can figure out what's going on here, what we know so far. So let's see. Well, remember, this right here was what? That's the ending amount. So what's the end percentage of adults married? The end percentage of adults married at the end of the time that is being kept in this chart is 45.9. Equals. What's the beginning percent, right? Remember, this is always the beginning amount. So the beginning amount of adults married was 72.2%. Let's see. So there's my 72.2. Part of the formula, E to the negative. Do I know what the rate is? Does it tell me the declining rate, the percentage that it's declining? It does not tell me. So I do not know what K is, but even though it doesn't tell me the amount of years, I know the beginning year and I know the end year. So I know how long it took to get from 72.2% to 45.9%? Well, it took from 1960 to 2012. So let's see, 2012 minus 1960. It took 52 years for this decline to happen. So I know that the T is 52. So let's see. Let's see what I do. And what am I looking for here? What the K is. That's what you're going to want in the first part of this answer. I'm trying to solve for K. What is the rate at which the people that are married is declining? So let's see. What I'm solving for is up in the exponent. That means at some point during this problem, how do you get things out of the exponent? You log both sides, or in this case, we're going to ln both sides since we're dealing with E. So, but before I can do that, let's get rid of the 72.2. Since it's hooked on, I'm just going to divide by it. So let's see. On the left, don't even do this math. Just keep it like that. 45.9 over 72.2 equals, let's see, I still have E to the negative K times 52. Let's see, how else could I write that? Instead of negative K times 52, I could think of that as negative 52K, right? So let's think of it, if we want it, you don't have to, negative 52K. So now, again, I'm solving for K, which means I need this to now come out of the exponent. That's when you ln both sides. So let's see, when I ln the right side, that's what brings the negative 52K out in front. I still technically have ln of E, but remember, that's equal to 1, so I don't even need it. So I just have negative 52K on this side. On the left, I've got this crazy looking fraction, ln of 45.9 over 72.2. So on the left, I have ln of 45.9 over 72.2. On the right, I have equals negative 52K. Well, if I'm solving for this K, I just need that negative 52 to go away. So just divide both sides by negative 52. Okay, so see what I'm doing over here? So I'm going to have K all by itself over here because the negative 52s are going to cancel. So the only thing that's going to be left on the right side is that K, which is what I'm solving for. I'm trying to define the rate at which the percent of married couples is declining. So here's what needs to go in your calculator. This whole side right here, if I can do this math, I'll know what the K is. So in my calculator, I need ln of 45.9 over 72.2, close parentheses, divided by negative 52. So let's look at what that looks like in your calculator. ln let's see, I've got 45.9 divided by 72.2, close. So again, 45.9 over 72.2. And then again, remember, what am I dividing that whole thing by? What's the denominator of that fraction? I'm dividing by negative 52 and hit enter. There's your rate. So let's see, how does it want that answer written? Round to 4 decimal places as needed. So let's see, I need 4 places after the decimal. So 0.00871. So the 1 makes the 7 not round up. So 0.0087 would be your K. So now I know that K, let's see, I'm running out of, is 0.0087. So I'm going to use that in further parts of this problem. Let's see, I'm still in the A part of this problem. Let's see, I think I can erase this now. So now that I know the K is 0.0087, now I can write in what the formula is going to be for the second part of this problem. It says M of T equals, let's see, the blank there. What's going to go in place of this? That's always your beginning amount. What was my beginning amount of percent of adults married? It was 72.2. E, now look, it's got the blank up in the exponent. Now remember, this is decay, which means this is the rate, but it needs to be negative. So negative 0.0087 T. So the things you had to fill in were the beginning amount and now the K, which we found in the first part of that problem. So let's see, using this formula now, since I know the rate, estimate the percent of adults who are married in 2015 and then again in 2018. So let's see, 2015. So let's think about what the chart was saying. What was the beginning year? Remember, the beginning year was 1960 from that chart. If the beginning year was 1960, and it wants to know the percent of adults who will be married in 2015. How many years is that? However many years that is what's going to go in place of your T now that you have the formula. So let's see, 2015 minus 1960 gives me 55 years. So 55 is now my T. So let's see, what's that going to say? I'm finding M of 55, which means I use my formula that I've created here, 72.2 E to the negative 0.0087. Instead of T, I put in 55. So let's see, I put this in my calculator, and that's going to tell me the percent of adults that are going to be married in 2015. It should be less than 45.9, right? If we're still going down, and in 2012 it was 45.9, in 2015 it should be even less. So let's put this in our calculator to see what we get. 72.2 E, so the second LN button. Now I'm up in my exponent, I type in the negative 0.0087 times 55. So that's what you should have looking in your calculator. Hit enter. It tells me, let's see, how does it want me to round it? Round to 1 decimal place as needed, and it tells me 44.743. So if I'm doing 1 decimal place, I want to stop at the 7, which means the 4 doesn't round up to 7. So it'll be 44.7. Can y'all see my decimal? 44.7 million, which sounds about right, correct? Because if it was 45.9, it should have gone down a little bit from there. So now it's 44.7. Now, the second part of B, I'm not going to work it out because it says in 2018. So if it started in 1960 to 2018, now that's been 58 years, which means you do this same exact problem, except you are replacing the T with 58. And then again, just punching this with the 58 there instead of 55 in your calculator to get your answer. Okay, at this decay rate, in which year will the percentage of adults who are married be 37%? So let's say what we know now. First of all, if it says in which year, that means we do not know the year. So I'm looking for T. I'm not going to know the T. Let's see. Which year were the percent? I do know the ending of adults married? Where does your ending always go? It's this right here. And it's saying which year will the percent of adults who are married be 37? So I know that's 37. 72.2 e to the negative 0.0087. I do not know t, right? That's what I'm looking for, is how many years is that going to take? So let's see. Again, I'm solving for something that's up in an exponent. What does that tell you? At some point in this problem, I'm going to have to ln both sides to bring that out of my exponent down in front of the e. But before you do that, you want to get rid of the 72.2. So divide both sides by 72.2. So let's see, now what do I have? Over here I've got e to the negative 0.0087t. On the left, I just have 37 over 72.2. Now is the time where you want to ln both sides, right? Because what does lnning do? It brings the exponent down in front of the problem. So now let's see what I have. On the right, I've got negative, because it brings this down now, 0.0087t. So this just brought this down. Again, I still have the ln e, but remember what that's equal to. That's equal to 1, so I don't need it. So all I have over here is negative 0.0087t. Over here, I have ln of 37 over 72.2. Again, 72.2. So let's see, if I'm solving for t, I just need to get rid of that negative 0.0087. So I'll just divide by it. Negative 0.0087. Do the same thing on the left. Divide by negative 0.0087. So once I do that, what's going to be left on the right? Well, the negative 0.0087s will cancel. I'm just left with the t. On the left, I have all this big mess, which I'm just going to type into my calculator. So let's see. I need ln, then I need 37 over 72.2, close. So there's going to be the first part of the ln, 37 over 72.2. Then what are you going to divide by? You're going to divide by negative 0.0087. Uh-oh. What did I do wrong? I must just typed it in wrong. ln 37 over 72.2 close divided by negative 0.0087. Oh, there it is. I don't know what happened. And it tells me 70. So here, I just must have typed it in wrong the first time. So ln of 37 over 72.2 divided by the negative 0.0087. And it tells me, let's see, what does it want me to do? Round your answer to the nearest whole number as needed. Now, we have to be careful here how they want your answer. So let's see. I got 76.8, which is really 77. But what does it say? It says, at this decay rate, in which year will the percent of adults who are married be 37%? Well, it's not the year 77. That wouldn't make any sense. So let's think about what this means. This is the number of years after the starting date. What was the starting date of the problem? It was 1960, right? That was the starting date in the chart. So I need to add that 77 to the 1960, right? So if I'm going to add 77 to that first year, which was 1960, I'll get the year 2037. All right, I see y'all, while y'all are frustrated on this. Hopefully this, seeing me work it out on the board like I would in class will help y'all more on these types of problems. Okay, number 5, the number of farms in a certain state has declined continually since 1950. So 1950, we know, is going to be our beginning year. In 1950, there were 80,718 farms. So that's my beginning amount. And in 1995, so 1995, the number had decreased to 20,739. So in 1950, there were 80,718 farms. In 1995, there are only 20,739 farms. Assuming that the number of farms decreased according to that model, that formula that we've been using, find the value of K and write the function that describes this situation. So let's see, remember, M of T equals M0 e to the negative kt. So let's fill in what we know. So let's see, what is the ending amount of farms? That's what always goes here. End amount, beginning amount. End amount is 20,739. Beginning amount, what was the amount at the beginning of farms? 80,718. E to the negative, I do not know the rate, that's what I'm going to try to find, but do I know the amount of time that it took to get from 80,718 farms to 20,739 farms? I do. It doesn't tell me, but I know it was from 1950 to 1995, which means I know it took 45 years for that to happen. So I know that the T is 45. So let's see, it wants me to find the K and then rewrite this formula that I could use to solve all other kinds of problems if I wanted to. So let's see, if I'm going to solve for K, again, it's up in my exponent, which means at some point I'm going to ln both sides. But first, let's get rid of the 80,718. So let's see, now I have 20,739 over 80,718. Let's see, that's gone. I've got the E to the negative, let's see, instead of K45, I'm going to write it as 45K. So now I want to bring that K out of my exponent. So now I'm going to ln both sides. So when I ln the right, now I'm going to have negative 45K ln E, again, remember that's 1, so I don't need it. So ln over here, I just have ln of that crazy fraction. Now, how do I get K by itself? I'm going to divide by negative 45. So that's going to give me my K, which is the declining, going to be my rate in which I'm declining. So let's see, type that mess into your calculator. ln 20,739 divided by 80,718. So there's going to be the first part of it. Close that parenthesis and then divide by negative 45. And let's see what I get. I get this 0.03019. So 0.03019. And I'm sure it's going to want me to round this. It looks like because it's multiple choice, all the answers are rounded to 3 decimal places. So 030. Does that 1 round that 0 up? It does not, which means 0.030 is the rate at which it's declining, which means if I put that in my formula, let's see, they're using P's instead of m's, I would just put negative up in this spot right here. So you would have P of t equals P of 0 e, the negative, the 0.030 would go right there, okay? Let me show you what it looks like here. So see how I chose the B because it had the negative. That's the rate that I just found, 0.030. And then the formula that went along with it. All right, last one. Number 6, there are currently 78 million cars in a certain country. So 78 million cars right now. Decreasing by 7.2% annually. So it's decreasing by 7.2%. So the numbers are going down 7.2%. How many years will it take for the country to have 57 million cars? So let's see. What am I finding here? So what do I know? I know the beginning amount, the end amount, and the rate. So let's see. I know the end amount, which is always on the left side. The beginning amount comes over here. E to the negative 7.2. Uh-oh, I was about to put in 7.2, but remember, we would need to put that in as a decimal. So move it 2 places to the left. Fill in your hole with a 0, so negative 0.072. Do I know the time? No, I don't. It wants me to find how long. So that's what I'm looking for, is that t. How long did it take to get from 78 million cars to 57 million cars? So again, I'm solving for t, so I'm going to have to ln in just a minute. Get rid of the 78. So now I have 57 over 78 equals e to the negative 0.072 t. Now ln both sides, because what am I trying to do? I need to get that this whole thing out of the exponent. So I'm going to ln both sides. So now on the right, let's see if this comes down in front. I have negative 0.072t ln e. Again, that's 1, which means you don't need it. So all I have on the right is negative 0.072t. On the left, I have negative 57, or not negative, why am I saying that? ln of 57 over 78. So what do I need to do to solve for t? Divide by negative 0.072. Negative 0.072. So here's what will give me my answer, right? Because this will cancel. All I'm going to have left on the right side is the t, which is the number of years that I'm looking for. So let's see. ln 57 over 78. So there's your ln 57 over 78. Divided by negative 0.072. And it tells me 4.3. Says round that to the nearest year. Since it's 4.3, that means it rounds to 4. And you're done.